This proof is asking me to prove that segment FG is congruent to segment GH, and the only thing that they tell me is that I have a circle with the center at O. All right, so you look at this and you think, well, I don't really have much to go on, right? I have some perpendicular lines here, but that's basically about it. So let's look at those perpendicular lines. That will tell me that I've got a right angle there and a right angle there. So let's go ahead and list that. I can say that angle FGO and angle HGO are right angles. And of course my reason there is just that if lines are perpendicular, then they intersect at a right angle. Okay? So you're looking at this and you're thinking, well, okay, so where do I go from there? Well, we've done triangle congruence for most of the proofs that we've done, and you look at this and you say, well, there are no triangles. And also, why is there a circle? What's the point of having a circle here in this diagram? But that's the point. I can draw in two additional segments and I can make triangles. Okay, so if I draw a segment there and I draw a segment there, now I have two triangles, okay? As a reminder, if you want to draw a segment, you just say draw and then the name of the segment. So in this case, it would be draw FO. And your reason is the 2 points determine a segment. Okay, and I can also, I'll tell you what, I'm going to go ahead and put this in the same line. I'm going to say draw FO and OH. Usually you put separate things in separate lines, but more or less the same information. Okay, those two segments are going to be congruent. So I've got that. I have the fact that FO is congruent to OH because they're both radii of a circle. So all radii of a circle are congruent, okay? And we're really close now. We've got a shared side here between the two triangles. So we can say that Geo is congruent to itself, and that's by the reflexive property. And at this point, we should be able to prove the triangle's congruent. If you look at it real quick, you'll think you have a side-side angle. But remember that those are both right triangles, and I've proved a pair of hypotenuses congruent. I have that right here. I've proved a pair of legs congruent with that GO statement, and I have right angles up here earlier. So I have everything I need. I can go ahead and prove the triangle's congruent. So I can say the triangle, it's going to be GFO is going to be congruent to triangle, so it's GFO, it's going to be GHO. And that's going to be by the hypotenuse leg rule, or sometimes I write hypotenuse leg right angle to remind myself that I have to have right angles. Once the triangles are congruent, I know that FG and GH are corresponding parts of those two triangles. So I can say that FG is congruent to GH because corresponding parts of congruent triangles are congruent. So pretty straightforward if you put those auxiliary lines in.